Hello, my name is Johnny Mandal, and I'm going to talk more about the code of the application Smash. Smash stands for Security Monitoring and Analysis System Host. So I used the IDE Eclipse, and the framework that I'm using is Spring, along with Thymeleaf for the UI enhancements. And as you can see that my project Smash is all loaded up here, and pom.xml, which is my Maven config file for the dependency and other required jars that I might need. So let's start with pom. It's taking a little longer than usual to open. So this is my pom, and here some of the, if not all, some of the important dependencies I would like to point out. One is the Thymeleaf for the various UI advantages that we want to bring in from Thymeleaf. Then the Spring Security, we have the Spring Security also pulled into this. That was the test. Here is this one, because we are also going to have security functionalities built all around our application, so that different users, based on their authorization, access the application and its features. So this was pom, and the structure of the application is all the code that lies under the source.main.java package, and it follows a very popular design pattern, MVC, model view controller. And we have our controller classes here. Then the application start, the start point of the application is here. Then models. Then I have the application security, which is kept separate. The service part, the service implementations, and some utilities. Now we have the resources. In the main resources, we have the various view pages, the HTML pages, and importantly the application dot properties. Before we take a look at the application properties, it is important to note that all of these classes, they have their respective test cases here. So here I have decided to test the controller classes, the security, and the service. It is for the unit test cases. So let's go to the application.properties. So here we can see the I've changed the port where the application can be accessed. The default is 8080. 8080 on my system is used by some other application, so I've used 8085. And then there are some configuration related, the credential related information here. I have two users for the demo. One is the admin and the other one is me, Johnny. The SQL driver related information, and then the upload, the data files. When the user uploads, it can be all going here. It can be a file server in the real time, and then the default locations for Elasticsearch, Logstash, and Kibana for the health check that is implemented as part of the application. So I have not modified the default ports, and they are as is. Let's go from top to down. I will not go through all the classes. I'll just touch the important ones. For instance, the Smash controller. So the Smash controller, all it does is it has the login functionality. It has home, the home screen, and then there are 3 dashboards that are implemented. So it takes care of that. And then upload functionality. For the upload, currently in the property files, we have specified 100 megabytes to be the maximum size of the upload, but it can very well increase based on the requirement. Say for instance, now the flow, if the user is here, he types on the URL home and the user is authenticated, then home.html is what the user is going to get. And Spring MVC, it takes care of all of this. The framework has that feature built in. It shows some information about what the application is and what are all the features it has. Here it is also trying to import a header. So this is where the Thymeleaf functionality comes in. I've also imported those at the top. So if you go here, we have the header and footer, and there are 2 layouts. So the default one, which I'm not using right now, I'm using the layout.html, which is a very simple layout where on top I have the header, then the container where all the content can be seen, and at the bottom footer, and the header and footer are imported from here. So any changes here, it immediately reflects all across the application. So this gives that kind of a flexibility even on the UI page. Now, similar to dashboard 1, we have dashboard 2 and dashboard 3, and then there is a universal error page. Any major application related error, any 500 plus error code will direct to this error page, and the user is not going to see a lot of exception, which could be very useful for the developers, but for a normal user, that is all junk. And the upload page, so all the important pages are here. Now going back to the controller, so this is what the controller does. And then related to config, we have few URL mapped here on the config as well. And this part, it takes care of, it's making a call to config service, and the config service is basically used to perform certain health checks on these various applications, because they are the backbone of Smash, and Smash does not require these to be up and running to start, but then to operate smoothly and to perform its various operations, intended operations, it needs these applications to be up and running, because the actual data is stored in Elastic and Kibana is taking care of the visualizations. This is the main application. This is like the main method that we will call in C or in Java. So we have the main method here, and this is the beginning of the program. ES index, because we are retrieving some Elasticsearch data right from its in JSON format, and then we marshal that and put all the data into this model. This is the most important part of the security, where we configure few things. Here I have, because all these properties, these credentials are hard coded in the property file, but this can very well go in a database for additional security, or it can very well be encrypted so that a normal user cannot read it or make out what the password is. Some security related information here. if you go to the service, I have my interface service and the implementation of the same here. It is checking, it has few methods. It is checking if Elasticsearch is alive, so it will check for Logstash and others, and it is looking for the code, the return code of the URL. If that is okay, then return true, otherwise false. And then the Elasticsearch indices, this is where my model is being used, and it does some kind of data massaging to get the status open, whether the node is open or not, the index name itself, the number of documents it has, and the size of it. And an additional information, the Smash config page also allows the admins to remove some of the nodes that they don't want, or maybe they have accidentally uploaded. So this is all that we have in the coding or the lifeline of Smash. Thank you so much.